And welcome back to Mr. Gregoris Math. So now we're taking a look at another sine law video. We have another non-right triangle here. You can see our angles are 40 degrees, 87 degrees, so that means that this one is not going to be 90 degrees. And that's all that we care about. If we had a right triangle, we wouldn't use sine law. We would only use sine law for places where we have non-right triangles. Now remember, sine law has two versions. It has the version that has the angle in the numerator and the side in the denominator. That's the version we would tend to use when we have an unknown angle. But in this case, we know all of the angles, so we won't use that one. We're going to use the reciprocated version, where we would have the unknown side length in the numerator and the angle in the denominator. Now, it doesn't matter whether I start with A's or B's or whichever, just so long as I'm talking about an angle pair relationship. So if I have an angle pair relationship, that means that I know an angle and a side directly opposing it. So there you can see I have 40 degrees and 8 centimeters opposing one another. So that means I can replace one of these ratios with those two values. And of course, my other ratio would be x and 87 degrees, and so that's going to make up my other one. So the unknown side I like to keep in the top left, just so that way I can keep my work looking kind of algebraically neat. So I'm going to replace b with x, and sine b is the one opposing x. So I'll have sine 87 degrees. This will be equal to side length a, which is 8 in this case, over sine of a, which is sine of 40 degrees. So I've now got this set up quite nicely. And if you don't know anything about sines and cosines and tangents, this maybe looks frustrating, but if you know stuff about proportions, it's not so tricky. If I want to get x alone, I just need to multiply through by the denominator. So I'll multiply both sides by sine 87, which will leave me with 8 sine 87 over sine 40. And I should be able to type that entirely in my calculator and get a final answer. Now, I expect my final answer to be larger than 8 because 40 is a smaller angle and 8 is a smaller side. So I expect it to be a fair amount larger than 8. Let's check and see if I can get this right. Now, I need to have a numerator and denominator, so I usually do that by setting a bracket to encapsulate my numerator. So this will be 8 sine 87, bracket closed, and I'll divide it by my denominator, which is just going to be, again, bracket sine 40. Some calculators, you don't need the brackets, others you do. I just like them because it makes it very clear that you're dividing not by sine, but dividing by sine of 40. Of course, dividing by sine doesn't mean anything, so it would lead to an error. So let's go ahead and hit equals and see what we get. Excellent, we got 12.42, which is larger than 8, which is what I was expecting. So that's how we use sine law to find an unknown side. We could do this again. So if we did 127 from 180, we get this angle, and we could find this side length here using sine law as well too. There is a case where you can't use sine law necessarily, and there's one other thing I wanted to show you on your calculator. So notice in my calculator, I don't know if you can see it, I'll tilt back, maybe you can see it. It says degree in the top corner. If your calculator doesn't say degree or radian right there, you may have run into an issue with having your calculator set in the wrong mode. If it does say radian and it's supposed to say degree, you'll have to go through your calculator's setup to change it back 2 degrees. It's another common error I see with my grade 10 students when first working with sine law. As always, don't forget to hit like, subscribe, ring that notification bell, and leave a comment. And if that comment is mathy or nerdy enough, we'll lead off our next lesson with just a hilarious representation of that on the screen somewhere. So hope to talk to you next time, and take care.